Okay, so this is section 3.2, so we're already getting into chapter 3. Now we're going to get into some of the calculations, some of the things that we do in statistics. So we're getting a little bit away from vocabulary. We still have some reasons and things that we have to know for vocabulary. Arithmetic mean is what we all think of as an average. If I'm going to get your test mean, I'm going to take all 4 tests at the end of the semester, add them up and divide them by 4. That is a mean. That's what we think of as an average. Okay? Some advantages is that it tends to vary less than some other methods, yes, or other measures of center. Advantage is that it takes every single data point into consideration. So as we talked the other day, if I were going to get an average mean for the first test, which I will, it would be very much affected by if some student did not come and take that test and got a 0. So that's the disadvantage of the mean being a measure of center, is simply because it can drastically be pulled one way or the other due to one piece of data, which we know can be called an outlier. Just so you have the notation there, some of that notation will be new. Capital sigma, and that's the sum of all the values, because when we give these formulas, you need to know what everything is representing. The x is the variable that is used to represent each individual data point. N is the number of data values in a sample. If it's little n, that's telling you it's a sample. If it's big N, that's telling that's a population. Remember, we always need to decide if we're dealing with a sample or if we're dealing with a population. So, you as the class, Statistics 255, Section 501, could be a population. I'm only including you in my population because you are my students in 255-501. In that case, you would be a population. Okay? However, if I was doing a study of all the students taking statistics here at the college this semester, you guys would be what? A sample. Okay? Difference between upper and lowercase n. So here's the notation. We already know that. We're going to sum up all the data, divide by the number, and this is how we're going to show it. And it's called X bar. And X bar is the mean of a sample. Okay? Mu, another Greek letter. We get to learn lots of Greek letters this semester. Mu is the population mean. Population mean. We're going to use those throughout the entire semester. X bar and mu, and you need to know which is which. So here's an example. There was a table there that includes the counts of chocolate chip cookies and different cookies. Find the mean of the first 5 counts for Chips Ahoy regular cookies. And there's the number of chips. So, am I doing this as a population or is this a sample? It's a sample, isn't it? Because I'm not going to count every single solitary cookie. I'm just doing a sample of 5. So I'm going to be using X bar, correct? And then I'm going to do what? Sum all of them, and divide by n. There's my formula I'm going to use, correct? So that means I'm going to take 22, add 22, I'm going to run out of room, 26, 24, and 23. And then I'm going to divide by the number of cookies I've used on my sample, which is 5, and good, everybody's on their calculators. $23.4. So 23, the mean number of chips in the Chips Ahoy is 23.4. Chips. 23.4 chips. Another measure of sample is something called the median. And the way I always remember it is when you're driving down the road and you have that thing we call a median, it's in the what? Middle of the road. And this is nothing more than the middle number. Okay? The key is you have to put them in order from smallest to largest, because if you don't put them in order, you're just haphazardly pulling something out. Okay? It's denoted by X tilde is the median. The nice thing about the median is that it is not affected by outliers. It's not affected by outliers. So we could use the sample with okay, so now it doesn't want to let go. There we go. No idea. Salaries at a particular company. And of course, Mr. CEO. So if everybody go ahead, everybody find the mean. Find the mean. Find the mean. Anybody got it yet? $46,500 is X bar, the mean, right? But now, if I say I want to find the median, if I want to find the median, I've already listed them in order, correct? It's going to be between what? So it's going to fall in between two data points, correct? So if that happens, what you're going to do is you're going to add the 2 and divide by 2. So I'm going to add 12,500 plus 13,500 and divide by 2, because I want the center in between those two numbers. So I believe we're going to get 13,000. So that's a great example of when the median would be a better measure. The median would be a better measure of center, because this was affected by that one high salary. Some cities, they have lots of data and things about how much the mean or median cost of a house is in particular cities. Many times if they have a large population of people who are like in the film industry or actors, they're going to pull that up so high, they're going to use the median instead of the mean. Okay, this is just telling you how to find the median. Of course, we already did that. If it's an odd number, of course, it's just the center number. It's when they have an even, I have to add them together and divide by 2. Okay, so here was a set of numbers here. First, you had to sort them to get them into order. So I've done that. What is the median? What is the median? 0.73. Okay, so again, there's some numbers, but there's an even number of numbers. We sorted them, we put them in order. What is the median going to be? .915, and you added these two together and divided by 2. That's the questions you want on a test, right? Easy stuff. The mode. It's the data point that occurs most often. It's the data point that occurs most often. Sometimes there isn't a mode. Sometimes there just isn't a node because there's not a data point that occurs more than once. Because on your exams, it could be that every single person in here gets a different test score. There wouldn't be a mode. So you can have something that's bimodal, meaning there's 2 values that had the same high amount. Let's just say there were 4 people who scored a 92, and there were 4 people who scored a 78, and everything else was 3 or less. That would be bimodal. Okay, you can have multimodal, more than 2 of the same greatest frequency, and of course we said you may not even have a mode. Okay, here's examples of mode. In A, what would my mode be? Because it occurs twice and no other piece of data occurs twice. How about in B? Yeah, it's bimodal, isn't it? Each of these have 3 times each. 88 is only twice, and 99 is once. So it is bimodal. Mm-hmm. Multi. Okay, good question. How about C? No mode. Bless you. Mid-range is the value midway between the maximum and minimum values in the original set of data. So let's say that the highest score on the test was 101, but the lowest score was a 0 because somebody didn't come and take the test. I'm going to take 101 plus 0, obviously, is 101, and divide by 2. So my mid-range would be And that's really not a good measure of center, is it? Because if I have an outlier that's a minimum or maximum value, that is highly going to be affected. Where if I had, where everybody was here and took the test, and I had a 101 and my lowest score was a 72. So I'm going to add those together, divide by 2, the mid-range. So that probably, the mid-range is a good measure of center in that case, because I didn't have that extreme value. Okay. As we saw, sensitive to extremes. I gave you that demonstration. What's nice about it is, man, you can compute that really fast. And it is another way of measuring center. Okay? So, how many different ways? We have mean, median, mode, mid-range. And we can see where some would work for some data and it was still the measure, it's just not a good measure. Okay, our round off rules for stats. In the cases where we would have data that's to the ones column, when we do our calculations, we're going to round it to the tenths column, 1 digit beyond what our data is. So in the case of GPAs, those GPAs usually have to the 100th space, correct? So what would you round to? To the 1,000th. Okay, so one place beyond what your data has. Okay, identify the reason why the mean and the median would not be meaningful. Rank by sales of selected statistics books, or B, number of jerseys on the starting offense for the New Orleans Saints. Would the mean or median rank of selected stats books, would the mean be meaningful? Would the median be meaningful? Because we're counting number of textbooks sold, right? What about this? Because the number really is just a representative of a particular person. It doesn't mean anything if we were to add all the jersey numbers and divide them, right? Wouldn't mean anything. Same thing with we did zip codes. They wouldn't mean anything. Or phone numbers, or social security numbers, or your 700 number at the college. So the formula that we just used for finding the mean was when I had raw data. Raw data means I know what every individual's test score is. Okay? Sometimes I'm not going to have raw data. Sometimes I'm going to get data in a frequency distribution, and I'm just going to have the classes and the class widths. So let's talk about how we're going to do it then. So I have a class width of 50 to 69 for IQ. We have 2 people. We're literally have to find this, you have to find. The class midpoint you need to find. So I'm going to add 50 and 6 to 69. I'm going to divide by 2 and get that class midpoint, the midpoint in that class. Then I'm going to take my frequency and I'm going to multiply by the class midpoint to get this value. And again, 33 times this, 35 times this. and then I'm going to sum them all, and then I'm going to divide by the sum of the frequencies, because I have to count every data point. I have to count every data point. Okay? So that can be a lot of work, right? So I would like for you to bring out your calculators. And of course, mine isn't installed on this machine. That's okay. I have a backup plan. Maybe. Okay. So first thing you have to do is we got to find some keys on the calculator to know how to do all these. So what I'm going to do is I will go through this very quick, very slowly, so that you can write down the keystroke and do the keystroke with me. So if you're starting to get lost, just wave at me so I can stop and wait, okay? So I'm going to click on Stat. If you have a new calculator, or you've had a calculator that maybe you haven't used for a while, or you borrowed it, wouldn't be a bad idea just to say number 5 to set up the editor and hit enter. Because if not, our lists might not be there. Okay? You don't have to do that every time. You just need to do that at the beginning. So once you've done it, you should be set. So I'm going to go to Stat. The first thing I have to do is put my data in there. The first thing I have to do is enter my data. So I'm going to do 1 for edit. I'm going to edit my data. Now you should see a screen like mine. It should say L1, L2, L3 for the columns along, okay? If you have data in your calculator, in your lists, what you'll do is use your cursor key, click on the name there, L1 is the name of the list, and we're going to hit clear and enter, and it will erase all of the data in that list. What you don't want to do is go up there and click on it and then hit delete, because then you've deleted the whole name of the column. Okay? So if you have it in there, you're going to go up, hit clear, nothing happens until you hit enter. Okay? So in L1, L1 is your X. That's my X, my horizontal axis. That's going to be my midpoint. That's where I would see my classes. The first one would be from 50 to 69. So I'm going to, though, I don't know if those two people have a 50 and a 51 for an IQ. I don't know if they have a 60 and a 68. I have no clue. I've lost the individual raw pieces of data. So I'm going to, in L1, enter all of my class midpoints. So the first one I'm going to enter is 59.5. I type it in and I press enter, and you'll see it come up in your list. Of course, the next one is 79.5, and I'm going to continue on down and enter each one of those class midpoints. I'm still hearing clicking, so I don't think everybody's quite ready yet. Okay, everybody ready? I'm going to now use my cursor key, and I'm going to cursor over to the right to go to L2. In L2, the frequency has to be entered. I'm going to make sure I enter the right frequency for the right class midpoint. So I'm going to enter 2 for the first one, then 33, then 35, 7, and 1. Sounds like everybody's finished. Now that I have my data in, I don't want to ruin my data. I want to get out of that, edit those lists. So I'm going to use second and quit. So now I'm best back out at the main menu, the main screen. I want it to do the calculations for me now. So I'm going to go back to the stat menu. I'm going to cursor to the right to where it says calculate. And I'm going to choose, in this case, number 1, which is one variable stats. I'm only looking at one variable. That one variable is IQ score. So, and I'll press enter. Now this is where it comes to be different. If you have my screen, just hold on for a sec. If you have a screen, I can see you have a different screen. Okay, you pressed enter. You pressed enter and pressed enter, didn't you? Yes, you did. See, I know. So if you have a TI-83 Plus and it just says one variable stats and it doesn't have that menu like mine, it's waiting for something. It's waiting for you to tell it where the data is. If you just right here hit enter, it's only going to look at L1. It will only look at L1. Okay? So with this calculator, I have to input. I'm going to go, I got to find it. Second and number 1, which is L1. And on your screen, it'll type L1. Then you've got to type this comma. The comma key is right here by the 7, right above the 7. So I'm going to type a comma. And then I'm going to tell it, hey, you also have to use list L2. If you don't use L2, you don't have any of the frequencies, right? So then I'm going to do second L2. And now you're ready to press enter. Okay? Those of you who have this one, like mine, your list is L1. You're going to cursor down. And where it says the frequency list, well, we put frequency list in L2, so I have to tell it L2. So that was second, and then the number 2, we'll type L2. Then I'm going to cursor down with calculate being highlighted. I'm going to go ahead and press enter. Those of you with the 83s, you can just press enter after you type L1, L2. Okay? And once we do that, then we both have the same screen again. Okay? So let's talk about what each of these mean. Wait, while we're on the screen. Ah. It won't bring it over. Okay. That's what I wanted it to do. Everybody should know what the first one is. X bar is what? Mean. Certainly beats the heck out of doing that by hand, doesn't it? Yeah. The second one is the sum of all those data. Exactly. This is something that they use. It's the sum of the x squares, and we use that when we're getting ready to get standard deviation. This one, SX, is a sample standard deviation. We haven't learned about standard deviation yet, but we are going to very soon. And the next one down is theta x, and that is the population standard deviation. Everybody knows what n is? The number of pieces of data that I had in my count there. So now I'm going to cursor down with my cursor key on my calculator, and I'm going to keep cursoring until I'm at the end, because it gives us more. We're not finished yet with all the good stuff. The minimum value is 59.5. The maximum value is 139.5. From that, could I get my mid-range? Add them together, divide by 2, right? Okay. We'll learn more about what a quartile 1 is, but quartile 1 is 25% in. Quartile for a quarter. Here's the median. That's, yeah, because that's at 50%, isn't it? And then, of course, quartile 3 is at 75% in. Okay, but that little bit, that gives you a whole lot of information right there by entering your data and using one variable, stat, and calculate. Okay? Weighted means when datas are assigned different weights. An example of this is how we compute your GPA. Because a 3-credit course isn't going to count as heavily in your GPA as a 5-credit course. Yeah, serious. It's not just, okay, I've got 2 A's and a B, and I'm going to add up 4, 4, and 3. It depends upon what the credit amount is for that course that you got an A in. The credit amount for a course. So in other words, the stats class that you're in right now is a 3-credit course. Anybody in here taking A&P? 1? Oh, and did? How many is that? It's a 5-credit course, right? So that particular course has 5 credits, and this one only has 3. So I would, if you got an A in this one, 3 times my 4, but in bio, if you got a B, you would take 5 times 3 because a B's worth 3. Does that make sense? Some of you are not sure about that, right? They're like, okay, let's do it. Let's give you an example. Stats 1, let's say you get an A in this class. English 101, that's a 3-credit course. Let's say you get a C in that. I would always get a C in English because I'm not a good writer. And I wouldn't even take A&P because I don't dissect anything. So we can say that too. Tell me another. Psych. What's a 4-credit course you guys have to take? Somebody tell me a 4-credit. Accounting. And let's say you got a B in there. Okay. So the credits, that's a 5-credit. That's a 3 credit. That's a 3 credit. That's a 4 credit. I'm not just going to add up because a B is worth, anybody know a B is worth 3, an A is worth, a C is worth, and a B is worth for our scale of GPA, correct? Well, we have to weight them all, so we're going to do 5 times 3 and get 15. 3 times 4 and get and 6, and we got to add all those up. $45. What am I dividing by, though? Anybody? What am I got to divide by? The number of credits. Sure, the number of credits. So what do I have? 8, 9, 10, 11, 15? So then I'm going to take my 45, divide by 15, so I can get my GPA, which is weighted, which of course in this count, I don't know how I figured that out, but I got it at 3.0. Isn't that like magic numbers, right? I have no idea how it ended up like that. Oh, yes, this is just for one semester. They would, yes. So when you see your transcript, you'll see the GPA for the semester, and then you'll see a cumulative GPA. So they'll go back and do every single course you've taken this fashion to get your cumulative GPA. That's too much, too much calculating, right? Yeah, and then here, just as a side, we do have grade amnesty, where if you fail a course and you retake the course, then the failing grade, so you retake it, you fail it, you take it, and you got a B. When they calculate your GPA, the failing grade is no longer calculated in your GPA, it's only the passing course. Okay? So that's great. Just remember, other colleges don't do that. Okay? So if you're looking to go to UT, they're going to figure out your GPA with those Fs. Oh man, yes. That is a weighted. That's a real good example of a weighted mean. Oh, look, I even had it there. See that? Okay. That is actually all for section 3.2.